So I promised some of you that I would do this predicting reaction products worksheet. Um, so I'm gonna work this thing out and periodic table. Okay. All right. So synthesis is real easy. It's real easy what's going on here. We have a zinc combining with a fluorine. And then we have to decide what the charges are, which you'll notice zinc is a transition metal, but that it only has one oxidation state. It's +2. So this is +2. Fluorine is -1. And they crisscross, so this 2 comes down here to this 2 comes here to this fluorine, and that 1 would drop down to the zinc. But then we have to balance this thing, and so I've got everything balanced here already. 1 zinc, 2 fluorines, 1 zinc, 2 fluorines. So I'm just going to work through all these. I have magnesium fluoride, that's -2, that's +2. I can keep showing the charges. Magnesium +2, but I'm going to count on the fact that you know that +2. What am I doing? Oh, so early in the morning. -2. Okay, so those cancel each other out, so it's just MgF. So I've got 1 fluorine, 2 on this side, so I'm going to throw 2 here. That gives me 2 magnesiums and 2 fluorines, so I guess I'm going to throw 2 here. 2 magnesiums, and I'm done. Now yesterday I had all these directions on the board. Actually, I think I can do this. Yep, those directions: identify cation and anion, change partners, crisscross oxidation numbers, balance chemical equation. Don't forget diatomics when they are alone, i.e. F2, Cl2, Br2, you know all those. Subscripts do not cross the arrow unless protected by parentheses. So, as long as we know these rules, everything's going to work out just fine. All right. So, identify cation and anion. Cation, anion. On these synthesis ones, it's not going to be so obvious what I need to do here. Identify cation, identify anion, crisscross. I need a 2 here, a 2 here, and that's balanced. I'm really just trying to get through these synthesis ones because -1, +1, 2, 2, and AG, so I can get on to the more interesting ones on the back. We're not doing decomposition because of all these special rules that they have for the way things decompose. We're not going to do that to ourselves. Oh wait, I'm shorting a step here, aren't I? +1, -2. I need to make some room in here. Oxygen is -2, so that 2 comes down here. So I know I need 2 oxygens. I only have 1. I'm going to throw a 2 out here. That gives me my 2 oxygens, but now I have 4 silvers, so I'm going to throw a 4 here. Done. All right. What I was really trying to get to is the more interesting and the things we care about more. These guys here. Okay, so we're going to work through the rules. Identify the cation and anion. Metals are always cations. Always. Everything to the left of this is going to be cations. So if I see a silver, I know that silver is a transition metal, it's a cation. If I see iron, I know that iron is a transition metal, it's a cation. They always end up plus something. Zinc, scandium, iron, hydrogen, cobalt, hydrogen, gold, aluminum, all these are metals. So you have to be able to identify these things. So I'm going to say, I'm going to put a plus under everything that's a cation. Okay, so that just leaves anions. So NO3, NO3, anions, all these things are anions. It says anions at the top. So NO3 is an anion, SO4 is an anion. Oh, I'm having such a hard time. There it is. ClO3 anion, PO4 anion, SO4 anion. And I'm going to go ahead and put the parentheses around all these things because I'm going to protect these subscripts as they go across this arrow here. All right, so step 1 is done. Identify cation and anion. And then step 2 is change partners. So we have Mr. Iron, and he is with Mrs. Nitrate, and he's going to leave, and she's going to leave Mr. Iron for Mr. Silver. So we have Silver, and I should leave more room for the subscripts and for balancing. So let's do that. Let's do this. We'll make a space. We'll put Silver, Nitrate, plus, now Iron is all by himself. A lot of people wanted to drop a charge down here or wanted to know what this thing is charged. If it's by itself, it doesn't matter. Because is there anything to crisscross the charge to? What you're trying to do is get a 0 charge, and this is positively charged. Am I ever going to add enough of positives together to get a 0? No. So, all right. So I've changed partners. Now I have to crisscross oxidation numbers. Now, Silver right here, +1. And NO3 is a nitrate. It's right here. It's -1. So those crisscross. So I'm done there. And then everything is balanced. 1 silver, 1 iron, 1 nitrate, 1 silver, 1 nitrate, 1 iron. Okay, so let's do the next one here. I'm going to leave blanks. Mrs. Sulfate is leaving Mr. Hydrogen for Mr. Zinc. So Mr. Zinc is getting an SO4 group. And Mr. Hydrogen is by himself. But do not forget, this is a diatomic. It is the second note on the board, or the first note on the board. Don't forget diatomics when they are alone. If hydrogen is alone, it has to be a subscript of 2. They do not exist as one sole atom by themselves. All right, so we've changed partners. Now we're going to crisscross. Zinc is +2. SO4 group is -2. Those cancel. And then we have 1 zinc, 1 sulfate, 2 hydrogens, 2 hydrogens, 1 sulfate, 1 zinc. So that's all balanced. All right, now this chlorate, ClO3. ClO3, chlorate. Yes, I'm correct. Excellent. Is going to leave Mr. Cobalt to be with Mr. Scandium. ClO3 plus, and now Mr. Cobalt is going to be all by himself. I hope that's enough room for it. And then Scandium, I told you, is +1. Chlorate is a -1. So those are crisscrossed already. 1 scandium, 1 cobalt, 2 ClO3s. So I have to put a 2 here. That gives me 2 scandiums and 2 ClO3s. So that means I have to put a 2 here, 2 scandiums, and I am done. It's just working the steps repeatedly and knowing what the steps are. Identify cation, cation, anion. We never put cations together, so it must be iron. Let's leave enough room for subscripts and stuff. OH2 by itself. And I said this iron is +2, and this phosphate is -2, -3, -3, -3. So we're going to crisscross, so that 3 goes to the iron. This 2 goes to the phosphate. Okay, now we have some actual balancing to do. I have 3 irons and 2 phosphates, so, and 2 hydrogens here. So I know that I'm never going to get that 3 to be a 2, and I'm never going to get that 2 to be odd. So I'm going to do this and just see what it does for me. So now I have 6 hydrogens, 6 hydrogens. You always want to multiply by the subscript of the other side. That'll give you a common factor. 2 PO4s, 3 irons. There we go. 3, 2, 1, 3. Again, it's just working the process over and over again. Identify the cations. Switch places. So aluminum. Again, I need to leave room for coefficients. And SO4. And I need to leave room for subscripts. So 4 plus, now it's gold all by himself. And then charges, Al is +3. And SO4 is -2. Crisscross, 3, 2. And, okay, so I identified the cation and the anion. I swapped places, so now aluminum's with the sulfate. Gold's off by himself. I crisscross charges to get my subscripts, and then we're going to balance. So I have 3 SO4 groups, 3 SO4 groups, 2 aluminums, 2 aluminums, 2 golds, 2 golds. Alright, I'm getting a little long on this video here, so I'm going to pause it and put up a second video.